Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A private database server can become reachable from the internet when several settings line up the wrong way. Its route table sends internet traffic to an internet gateway, it has public addressing, and its security controls allow the connection. Routing is only one piece of that picture, but one wrong route can turn a private design into one that is much easier to expose. Security groups and network ACLs control which connections are allowed. Route tables control where those connections can go. Today we turn to that routing layer, because public access and private outbound access use different paths. Quick recall from Part 2. A subnet's public or private nature depends on its route table. If it has a route that sends general internet traffic toward an internet gateway, it is typically treated as public. Attaching the gateway alone is not the whole story. A private subnet, in contrast, does not route general internet traffic to that gateway. This routing difference is the foundation for today's two gateways. By the end of this video, you will be able to do three things. First, explain the exact difference between an internet gateway and a public NAT gateway. An internet gateway can support inbound and outbound internet communication for properly configured public resources, while a public NAT gateway enables outbound internet access for private resources. Second, choose the right route table target for public and private subnets, including the IPv4 default route 0.0.0.0/0. Third, choose the right high availability pattern. One zonal public NAT gateway per availability zone in the classic subnet-based design, or a regional NAT gateway when its automatic multi-AZ model fits the workload. You will also understand where NAT gateway cost comes from and how to avoid cross-AZ traffic surprises. Picture a backend API in a private subnet. Every night it tries to pull packages and call an external payment service. Every single attempt fails because the VPC has no path to the internet. The public-facing web server has a different problem. Customers need to reach it, and it also needs to respond. That's why it helps to have two different tools. Public-facing resources typically need inbound plus outbound. Private resources usually only need outbound. Those two patterns point in different directions. An internet gateway is the component that connects a VPC to the internet. Think of it as a shop with a glass door facing the street. Customers can walk in and staff can step out, but only if the shop is actually configured to receive them. For an IPv4 resource to use that path, three pieces must line up. Its subnet route table needs a route to the internet gateway. The resource needs a public IPv4 address, or elastic IP, and the security group and network ACL must allow the traffic. The internet gateway creates the path. It does not automatically open the door. Quick recall check. A web server in a public subnet needs to serve users over HTTPS. Which AWS gateway provides the internet path? And what must be true before users can actually reach that server? The gateway is an internet gateway. The subnet route table must point its default route at that gateway. For IPv4, the instance also needs a public IPv4 address or elastic IP, and the security controls must allow HTTPS. A route alone does not make the server reachable. Let's build the Internet Gateway Path with the AWS CLI. Replace the example VPC and route table IDs with your own values. Bash IGW ID AWS EC2 create Internet Gateway. Yach query Internet Gateway ID YAS output text. YAS E2 attach Internet Gateway shot. Internet Gateway ID IGW ID has VPC ID VPC 3468 updef EC2 create route route table EDE authorate updef burn. Destination CIDR block 0./learn. Gateway ID agwady. That last command is the part people skip. It creates the IPv4 default route from the public route table to the Internet Gateway. If your workload uses IPv6, add the matching 0 route deliberately. And remember, the instance still needs public addressing and allowing security rules before it can use the path. Quick recall check. You attach an Internet Gateway to the VPC, but you never touch the route tables. Can an EC2 instance in one of the subnets reach the Internet? No. Attaching the gateway alone does not create a path. The subnet becomes public only when its route table has a route to the Internet Gateway. For IPv4 connectivity, the instance also needs a public IPv4 address, or elastic IP. Routing, addressing, and security controls all have to line up. Here is the beginner trap. Someone says, this app server needs the internet for updates, so put it in a public subnet. That is usually broader exposure than the workload needs. A safer pattern is to keep only the public entry point, such as an application load balancer, in a public subnet. The application server and database remain in private subnets. The application server can still make outbound internet calls through a public NAT gateway or a regional NAT gateway, while the database can remain without any direct internet route at all. Private does not mean disconnected. It means the path is deliberate and does not accept unsolicited internet traffic. Now think about the problem a NAT gateway is designed to solve. A backend API sits in a private subnet, deliberately kept off the public internet, because you don't want strangers reaching it. But it still needs to download packages and call an external payment API every night. Without an outbound path, those calls fail. It's like a locked server room with a phone that can only dial out. Someone inside could call the outside world, but nobody outside can call back into the room. That outbound-only line is the idea behind what a NAT gateway does. The classic fix is a public zonal NAT gateway. A private EC2 instance sends internet-bound traffic to that NAT gateway. The NAT gateway is deployed in a public subnet, has an elastic IP, and its subnet route table sends internet traffic to the Internet Gateway. The NAT gateway translates the private instance address for the outbound connection. The Internet Gateway then maps the public NAT gateway's private address to its elastic IP for internet communication. From the Internet, the traffic appears to come from the NAT gateway's elastic IP, not from the private instance. The private subnet's route table points its default route to the NAT gateway. That is the actual outbound path. If you remember nothing else, remember the direction and the prerequisites. An Internet Gateway can support inbound and outbound internet communication for a resource that has the correct route, public addressing for IPv4 or IPv6 addressing, and allowing security controls. A public NAT gateway is for outbound internet access from private resources. The private resource initiates the connection. The NAT gateway carries the reply back to that same flow. Same internet, different trust model. The Internet Gateway is the public path. The public NAT gateway is the private resources controlled outbound path. Now create the classic public zonal NAT gateway in the console. Inside VPC, open NAT Gateways and choose Create NAT Gateway. Select Zonal Availability and Public Connectivity. Choose a public subnet in the availability zone you are serving and allocate an elastic IP. That elastic IP is the address used for outbound internet traffic. Before you create it, verify that the selected public subnet's route table already has a default route to the internet gateway. Then create the NAT gateway. Next, open the route table for the private subnet in the same availability zone. Add an IPv4 default route 0.0.0.0/0 with the new NAT gateway as the target. That route is the private subnet's outbound internet path. If you choose a regional NAT gateway instead, do not select a subnet. Regional NAT gateways are VPC-level resources that AWS expands across availability zones automatically. Quick check. In a private subnet that needs outbound IPv4 internet access through a public zonal NAT gateway, what target should the default route point to? The answer is the NAT gateway, not the internet gateway. The NAT gateway is the private subnet's outbound path, and the NAT gateway's own public subnet routes onward to the internet gateway. For a regional NAT gateway, the private subnet route also targets the regional NAT gateway ID, but AWS manages the gateway's multi-AZ expansion and internet path for you. Here is the misunderstanding that trips people up. A public NAT gateway has an elastic IP, so people assume it works like a front door that anyone can knock on. It does not. A public NAT gateway is designed for connections that begin from inside the VPC. A private instance starts an outbound connection, the NAT gateway translates it, and the reply is allowed back to that matching flow. A brand new unsolicited connection from the internet does not become a connection to the private instance. And do not generalize the elastic IP detail to every NAT type. A private NAT gateway has no elastic IP, and a regional NAT gateway is managed differently from a zonal NAT gateway. Here is the precise model for a public NAT gateway. A private instance starts a connection to an external service. The NAT gateway translates that flow as it leaves the VPC. When the external service replies, the NAT gateway recognizes the response as part of the existing connection and translates it back to the private instance. A brand new connection from the internet has no matching flow started from inside the VPC. The public NAT gateway does not turn that inbound connection into access to your private workload. That is why a private application server can download updates or call an external API without becoming an internet-facing server. Let's troubleshoot a problem you'll eventually see in the real world. You launch an EC2 web server and give it a public IPv4 address. Its security group allows inbound HTTPS on TCP port 443. The VPC has an internet gateway attached. Everything looks right. But users on the internet still cannot reach the website. What's missing? Check the subnet's route table. Attaching an internet gateway to the VPC does not automatically send traffic through it. The subnet's route table also needs an IPv4 default route, 0.0.0.0/0, pointing to the internet gateway. Now you have the complete path, public addressing on the resource, a route from the subnet to the internet gateway, and security controls that allow the connection. When troubleshooting internet connectivity, don't randomly change firewall rules. Check the path in order: addressing, routing, security, then the application. A public IP without the right route goes nowhere. A route without the right security rules gets blocked. And perfect AWS networking still won't fix an application that isn't listening on the expected port. The CLI version has one important trap. The target on the private route table must be the NAT gateway, not the Internet gateway. Replace the example IDs with your own. Bash AWS EC2 create route aids. Route table, ID RTBs YR357889ABCDF0 warns. Destination, CIDR block 0.0.0.0/0. NAT gateway ID, NAT UO3 EOBEs. For a public zonal NAT gateway, this route sends private subnet internet traffic to the NAT gateway in the same availability zone. For a regional NAT gateway, the route also targets the regional NAT gateway ID, but AWS handles the cross-AZ expansion. Without this route, the private subnet has no outbound internet path even if the NAT gateway exists. 2 answers, one new and one older. Question 1. Which AWS component provides the internet path that can support unsolicited inbound connections to a properly configured public resource? The Internet Gateway. The resource still needs public addressing and allowing security rules. Question 2. Can a VPC endpoint replace a NAT gateway for reaching Amazon S3? Yes. A gateway VPC endpoint for S3 lets private subnets reach S3 without using a NAT gateway or the public internet. That can simplify the path and reduce NAT data processing costs for S3 traffic. Now let's talk about a NAT gateway detail that surprises people after deployment. Cost. Don't think about NAT gateway cost as just the price of creating one resource. Think about the entire traffic path. A NAT gateway can have charges associated with how long it exists and how much data it processes. If workloads in another availability zone send traffic through a zonal NAT gateway, the architecture can also introduce cross-AZ data transfer considerations. Then ask another question. Does this traffic need NAT at all? If private workloads are sending large amounts of traffic to supported AWS services, such as Amazon S3, a VPC endpoint may provide a private path without sending that traffic through the NAT gateway. So when reviewing NAT cost, ask 4 questions. How many NAT gateways are running? How much data are they processing? Is traffic crossing availability zones unnecessarily? And can some AWS service traffic use VPC endpoints instead? The cheapest NAT traffic is often the traffic you never send through NAT in the first place. Always verify current prices with AWS pricing documentation or the AWS pricing calculator before making a production cost estimate. Here are 4 NAT gateway cost traps worth checking in a real AWS environment. First, idle gateways. A NAT gateway can remain deployed even when very little traffic uses it. Review your environment for gateways left behind by labs, old applications, or abandoned environments. Second, unnecessary NAT traffic. Not every connection from a private subnet has to travel through a NAT gateway. For supported AWS services, VPC endpoints can provide a private path and may eliminate NAT processing for that traffic. Third, cross-availability zone traffic. If workloads in one availability zone send traffic to a zonal NAT gateway in another, you have created an unnecessary cross-AZ path. For the classic zonal design, keep private workloads using a NAT gateway in their own availability zone when possible. Fourth, forgetting the data processing component. A NAT gateway isn't just something that exists, it processes traffic. High-volume workloads can therefore change the economics significantly. Use AWS Cost Explorer and your billing data to identify NAT gateway spending. Then use the AWS pricing calculator and current AWS pricing documentation when estimating a new architecture. The goal isn't simply to make NAT cheaper. The goal is to make sure you're paying for NAT only where the architecture actually needs it. For the classic zonal NAT gateway design, one NAT gateway serves one availability zone. If workloads in other zones route through that one gateway, their traffic crosses availability zones before it reaches the internet. That adds a dependency and can add cross-AZ data transfer cost. The resilient zonal pattern is one public NAT gateway in each availability zone that contains private workloads needing internet access. Each private subnet routes to the NAT gateway in its own zone. That keeps traffic local and limits the blast radius of a zonal problem. AWS also offers a regional NAT gateway. Instead of creating one gateway per zone, you create one regional resource for the VPC. AWS automatically expands it across availability zones where your workloads run and provides high availability by default. Check availability and current guidance in your region before choosing the model. This is the modern high availability comparison. With one zonal NAT gateway serving every zone, other zones may have to send traffic across availability zones to reach it, and a problem in that gateway can affect every zone that depends on it. With zonal NAT gateways deployed one per availability zone, each private subnet uses a local gateway. That is the classic resilient design, but it means more gateways to manage and pay for. With a regional NAT gateway, AWS automatically expands the gateway across the availability zones where you have workloads. That can simplify route tables and provide high availability by default. Regional NAT gateway is for public NAT internet access use cases. If you need private NAT connectivity to another VPC or on-premises network, use a zonal private NAT gateway. Here is the recall check. You have private workloads in two availability zones. If you use one zonal public NAT gateway for both zones, what are the main risks? The other zone may send traffic across availability zones to use it, and a problem at that gateway can affect both zones. What are two better designs? Use one zonal public NAT gateway per availability zone, or evaluate a regional NAT gateway that automatically expands across the availability zones where your workloads run. Before NAT Gateway existed, AWS customers commonly used NAT instances, EC2 instances, configured to perform network address translation. They still work, but there's an important operational difference. A NAT instance is your EC2 instance. You choose the instance size, configure the operating system, manage patches, monitor capacity, design failover, and maintain the networking configuration yourself. A NAT gateway is managed by AWS. You don't patch an operating system or resize an EC2 instance when traffic increases. That removes much of the infrastructure management associated with running NAT yourself. So why would you ever encounter a NAT instance? Legacy environments may still use them, and some specialized architectures may need greater control over the underlying instance or networking behavior. But that flexibility comes with operational responsibility. For most standard outbound NAT requirements, start by evaluating the managed NAT gateway options rather than building your own NAT infrastructure. The interview-level distinction is simple. NAT instance, self-managed EC2-based NAT. NAT gateway, AWS-managed NAT service. Managed services usually reduce operational work, but architecture, availability, functionality, and cost still determine the right choice. Most people hear NAT gateway and immediately think internet, but AWS also offers a private NAT gateway. It has no elastic IP and it does not provide internet access. In fact, if its traffic is routed to an internet gateway, the internet gateway drops it. A private NAT gateway is used when your resources need to reach another VPC or an on-premises network through a transit gateway or virtual private gateway. The NAT gateway performs address translation. The transit gateway or VPN provides the path between networks. This is useful when the destination only allows a small source IP range, or when two networks have overlapping address ranges and need a translated path to communicate. A private NAT gateway still prevents unsolicited connections to the private resources that use it. This is the route table click path that matters for a public zonal NAT gateway. Open the VPC console, choose Route Tables, and select the route table for a private subnet. Click Edit Routes, then Add Route. For destination, enter 0.0.0.0/0. For target, choose NAT Gateway and select the public zonal NAT gateway in the same availability zone as that subnet. Save. That one route line gives private instances an outbound IPv4 internet path through the public NAT gateway. Skip it, and the NAT gateway is unused. For a regional NAT gateway, add the same default route but select the regional NAT gateway ID. Do not try to place a regional NAT gateway in a subnet. AWS manages the multi-AZ placement. For a private NAT gateway, use a specific route to the remote VPC or on-premises CIDR, not an internet default route. Quick recall on the private NAT nuance. A private subnet needs to reach an on-premises application, not the public internet. The network already has a site-to-site VPN or transit gateway path to that destination. The on-premises team only allows traffic from a small approved source IP range. Which NAT type fits? A private NAT gateway. It translates the source address to an approved private range, while the VPN or transit gateway carries the traffic to the remote network. It does not need an elastic IP and it does not use the Internet Gateway. A common secure design keeps the public footprint small. User traffic enters through the Internet Gateway into a public-facing tier. That tier then communicates with backend services over private addresses inside the virtual network. When the backend needs to call an external service or download updates, it goes out through a NAT gateway. The database sits with no direct internet route at all. That way, only the entry point is exposed, and the rest stays private. A common beginner mistake is treating public subnets like the default. When every server gets a public IP, you widen the attack surface. Any misconfigured security rule can expose internal resources. A safer design keeps the public footprint small. Typically a load balancer or web tier in public subnets, while application servers and databases remain private. Those private resources use a NAT gateway for whatever outbound calls they need. That is the least exposure approach. Here is the full web application path in one view. A user makes a request to a public entry point. That resource has a route to the Internet Gateway, public addressing where required, and security controls that allow the request. From there, traffic moves to the application tier using private addresses inside the VPC, never over the public internet. When the application tier needs to call an external API or download updates, it uses a public zonal NAT gateway or a regional NAT gateway. The database remains with no direct internet route. For this architecture, public resources use the Internet Gateway Path. Private workloads use a controlled NAT path for outbound internet access. Other needs can use other routes, such as VPC endpoints for AWS services, or private NAT through Transit Gateway or VPN for private network connectivity. No need to create anything here, just verify. Open the VPC console and select your VPC. Under Internet Gateways, check whether an Internet Gateway is attached. If the attachment is missing, resources cannot use a route to that internet gateway for internet connectivity. Next, open NAT gateways and identify the type you're looking at. A public zonal NAT gateway has an elastic IP and is deployed in a public subnet. A private NAT gateway has no elastic IP and is used with transit gateway or VPN routing to private networks. A regional NAT gateway is not deployed in a subnet. It is a VPC-level resource that AWS expands across availability zones. Then check the route table. A public zonal NAT gateway needs its public subnet to route to the internet gateway. A private subnet needing outbound internet must route to the public or regional NAT gateway. 30 seconds of checking the NAT type, route table, and internet gateway attachment catches most gateway misconfigurations. 5 mistakes worth memorizing. First, attaching an internet gateway but forgetting the route table entry. Attachment alone is not enough. Second, assuming an internet gateway route alone makes an IPv4 instance publicly reachable. The instance also needs a public IPv4 address or elastic IP, and the security controls must allow the connection. Third, placing a public zonal NAT gateway in a subnet without a route to the internet gateway. Public zonal NAT needs that public subnet route. Do not apply that rule to private NAT or regional NAT. Fourth, using one zonal NAT gateway for every availability zone without considering cross-AZ traffic and resilience. Use per-AZ zonal NAT gateways or evaluate a regional NAT gateway. Fifth, assuming a public NAT gateway accepts unsolicited inbound connections because it has an elastic IP. It does not. Public NAT is designed for connections initiated from inside the VPC. Now let's see whether you can design the architecture instead of just memorizing the gateways. You are building a web application across 2 availability zones. You have an internet-facing application load balancer, 2 application servers, and a database. Users on the internet need to reach the application. The application servers need outbound internet access for software updates and external API calls. The database does not need direct internet access, and you want to minimize the number of resources exposed to the internet. Where does everything go? Start with the application load balancer. It belongs in public subnets with a path to the internet gateway because it is the public entry point. The application servers belong in private subnets. Users do not connect directly to them. The load balancer forwards application traffic to them over private networking. When those application servers need outbound internet access, their private subnet route tables send internet-bound traffic to a public NAT gateway, or to a regional NAT gateway when that model fits the architecture. For the classic zonal design across 2 availability zones, deploy a public NAT gateway in each availability zone and have each private application subnet use the NAT gateway in its own zone. Finally, put the database in private database subnets with no direct internet route. The application tier reaches it privately, and its security group should allow only the application traffic the database actually requires. Now look at the architecture from the internet. Internet gateway, application load balancer, private application servers, private database. When an application server initiates an outbound internet connection, the path changes. Private application server, NAT gateway, internet gateway, internet. That's the architecture behind the definitions. The internet gateway provides the public path. The NAT gateway provides controlled outbound access for private workloads. and the database stays off the internet entirely. If an interviewer asks, "What's the difference between an internet gateway and a NAT gateway?" don't just say public versus private. Give them this answer. An internet gateway connects a VPC to the internet and supports internet communication for properly configured public resources. For IPv4, that means the resource needs public addressing, the subnet needs the correct route to the internet gateway, and the security controls must allow the traffic. A public NAT gateway solves a different problem. It allows resources in private subnets to initiate outbound internet connections without making those workloads directly reachable through unsolicited inbound internet connections. In a typical three-tier architecture, the public entry tier uses the Internet Gateway Path, application servers remain private, and use NAT when they need outbound internet access, and databases can remain private with no direct internet route at all. That's the answer that shows you understand the architecture, not just the definitions. And if the interviewer wants to go deeper, mention 3 more things. For a classic zonal design, consider one public NAT gateway per availability zone for resilience, and to avoid unnecessary cross-AZ paths. For supported AWS services, such as Amazon S3, consider VPC endpoints instead of sending everything through NAT. And remember that private NAT gateway solves a different problem. Address translation for private connectivity to other VPCs or on-premises networks through paths such as Transit Gateway or VPN. If you can explain those differences clearly, you're no longer just memorizing AWS networking terminology. You're thinking like someone who can design and troubleshoot the network. Next up in this series, Part 5 digs into Amazon Route 53, DNS, domain registration, routing policies, and health checks. That is the piece that turns your domain name into the right IP. Before that, practice today's path in an AWS Skill Builder lab or a small sandbox VPC. If you create a NAT gateway, check current pricing first and delete the NAT gateway as soon as the lab is finished. NAT gateways can incur hourly and data processing charges while they exist. Reading does not stick like clicking the console. If this series is moving your cloud skills forward, subscribe so you catch Part 5. See you there. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.